All right, so we're going to continue with what we were doing with finding the distance between 2 points. So then this is a different pattern. We still are building the same marching band, and now we want to find. They're adding some more ribbons. They're like, I think when they finish the ribbons, they're considering using to make this new picture. So they're going to try to go with this hexagon, and it's not a regular hexagon. You'll notice that AB is longer than, or appears to be longer than BC, and so we have to kind of look into that and see if it's actually longer or smaller. And we can do all of that, but we're not actually concerned about any of that. What we want to know is if the original ribbon, which was between Gabriella and Courtney, which we know is 5 meters, and the ribbon between Gabriella and Brittany, which was 5.6 meters, if I recall. Yep, 5.66 meters. If that same ribbon will be long enough to stretch between Brittany over here and Courtney right here, and I'm going to circle those. We're trying to find out how far apart these two are. And so I'm trying to think of what I could do to figure that out. So if I'm looking at this and I'm trying to figure out how to do it, I'm going to go ahead and drop a line straight down, and it looks to me like Brittany's position is at 3, 4, and Courtney's position is at 5, 0. So I could probably use that to help me. Oh, look, what I might have just created. A little right triangle. I guess it comes back to what we talked about yesterday, which was the Pythagorean theorem. So I could use that. This is 2, and this is 4, and I could use that. So I'm going to call this distance between Brittany and Courtney, I'm going to go with C. Just because it's hypotenuse, and that makes things easy. I was tricky on the last one. So I'm going to end up with 4 squared plus 2 squared, which is 16 plus 4, which is 20. And I'm going to have to take the square root of that to figure out what I get. So the square root of 20 was approximately 4 something. I'm going to grab my calculator to figure out what it is. So there's the calculator. You can still see my square root of 32 on there. And so 20 square root gives me 4.472. So rounding will be 4.47 meters. So was it long enough is the question. So we found out how long it has to be, but the question is still not answered. The question is, will the ribbons used in number 1 be long enough in number 3? So I'm going to leave you to explain that answer, because we've got a number, but it's not the answer to the question. The answer to the question is yes, they'll be long enough because blah, 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 or no, they're not long enough because blah, blah, blah. So make sure you answer and fill in the blah, blah, blahs, because blah, blah, blah doesn't mean anything. We're going to skip the rest of this task till tomorrow. And so we're going to move into this ready, set, go in just a second. Okay, so we're looking at the ready, set, go. And normally we do the ready before we do it. We're going to go ahead and do it now. It says, use the number line to find the distance between the given points. The notation AB means the distance between points A and B. So A to E, from here to there. Now we can either count, but if I'm looking at the counting, this is 2 and this is 0, and there's more than 2 spaces there. So I think I really want to just do AB first, just kind of as an example. AB, the distance is 0.5 because it's half. So 0.5, and it doesn't say how long everything is, so we're going to say units. And so from -4 to 2, I think that from -4 to 0 is 4, and from 0 to 2 is 2, so 4 plus 2, which is 6. Then from C to F, I'm going to do that one more, and then I'm going to leave you to do the rest. From C to F is from -2 to, gosh, that one's 3, so that one must be 2.5. And so that's 2, and that's 2 more, and that's 2.5. So CF is 2 plus 2.5, which gives me 4.5. So those are our two answers. I want you to go ahead and pause the video and then answer the last 4 questions. We'll do number 7 together. So now I've written the answers in green. So from G to B is 7.5. So from G to B is 7.5. So if we go here, that's 4. And this was 3.5 more. And so 7.5. C to A is 2. B to F we'll get back to. And E to G is 2. So B to F is the one I really want to spend some time talking about. So B is at -3, my pen, -3.5, and F is at 2.5, and so this is a positive 3.5 away from 0 and a positive 2.5 away from 0, giving us a total of 6 spaces. So what is a way to find distance without counting? Now I didn't count ever because of the halves, but I kind of counted to get here, like I went, okay, 1, 2, and a half. So is there another way to do it? I'm going to use B to F as my example to kind of explain. If I take F, which is the positive one, and subtract B, so I'm starting with the one on the right, and moving to the one on the left, and so gives you, that becomes 2.5 plus 3.5, which gives me 6. So that way, by knowing what the number is that it belongs to, I can just subtract the one on the right minus the one on the left, and that gives me the answer. So I'd like you to go ahead and finish describing this. AC should be drawn in. I don't know if it is in your book. I hope it is. And go ahead and see what's going on. Find those lengths. Remember, you might want to use the Pythagorean theorem and why, and then answer question 9, explain why it's easier, and then explain how. I think I gave you a hint with the Pythagorean theorem. And so then that will be part of your homework to finish that. Your other part of your homework today is going to be the Go. And there are 2 questions in the Go, but they're a little funky, except for they're not really. They're looking for some ordered pairs. So I'm going to go ahead and help you fill out just this one. I'm going to do find all the ordered pairs with you, and then we're going to do part A, and then the rest of it's your homework. So you'll have 1 through 10, most of which we've gone over, and then 16 and 17 is your homework. So this is 0, 0, and this we know is comma 0 because it's on the x-axis, and G is also comma 0 because it's on the x-axis. That looks like a 6. And then on the y-axis, these 2 ordered pairs are 0 in front on the y-axis. So that's what I've got. And then here, these are all -4 because they're at the same distance, vertical distance away from the x-axis. And these ones are the same. Gosh, this is confusing. Wait, okay, I got a 6. So these must both be 6 because they're the same vertical distance away from the axis. Now, I got to figure out those first ordered pairs. Is there something? Is there a hint? Okay, there is. All right. So we've got, see, now D has a 10 on it. And so that's the printed 10. And I know that those are the same horizontal distance from the origin. So these are all 10. And so now that I have those as all 10s, and make sure that's 10, 0 and not 100, I can use that to help me find the ordered pair, find the information it wants. So it wants to know the distance between H and B. So H and B, wait, excuse me, these are -10s. I don't know what I'm doing here, -10s. H and B, which goes from -10 to +10. So I think that, well, that's going to be 10 moving this way and 10 more this way, making a total of 20 units. And so that's what you're going to be doing. So you're going to figure out part B by yourself, and then go ahead and do number 17, which you'll have to fill in all the ordered pairs first, and then do what we did to answer the 2 questions. So good luck, and I'll talk to you for our set of videos tomorrow.